Hello guys, so as I said, I'll be posting some videos about artificial intelligence and its applications and some theory as well. So uh, to start, we can define artificial intelligence um by saying it's the science to make things mimic either human or animal behavior sometimes. And it's a very broad um, definition. By this rationale, we could say that there were some attempts to artificial intelligence by the 17th century, like the Pascalian. The Pascalian was created by Blaise Pascal in 1642. At the time, it was created for he was still a child or a teenager, and he created this machine to help his father with tax calculations. And it operated autonomously with some logic rules to be able to do additions and various other operations. But the most important thing is that it was persecuted to some extent by the church, and so it sparked at least some religious and theological um, uh, conversations because it mimicked human intelligence, and it was a machine that was operating for um, for things that were considered to be only human. But yeah, to be fair, we've seen real artificial intelligence application um, within uh, the, uh, the the 90s and the 2000s. For example, we can now analyze and um, predicts. Yeah, we can make prediction based on data, either yeah, either with images or text data. So uh, let's explain what happens behind the scenes. So when we talk about machine learning, there are three main categories. The first one is supervised learning. Supervised learning is when I try to train a model on a data set, and I have where I have labeled data. So let's say we're making a model to train on some images, and to say if this image is an image of a cat or a dog, um, and in this situation, we would have images presets of cats. We know that these images represent cats and these images represent dogs. And we train the model and using various algorithms that I hope I can cover in another video. But basically, it trains to know what makes a cat and what makes a dog. So when we feed it an image that it hasn't seen previously, it can know where to classify it. Is it a dog or a cat? In unsupervised learning, we don't have labels on data. But how it works exactly, I will give an example of, um, let's say, a bank having all its clients' data, and we can apply some unsupervised learning algorithms where it can know where it can know and calculate segments on the data, saying, for example, there are three categories on this data um, that would correspond to, for example, um, um, VIP clients and middle class clients and lower class clients. Uh, this is useful for, let's say, when the bank wants to advertise something, it can know which class to advertise to and not advertise the whole campaign to all its clients, but do it more in a smarter way. And reinforcement learning is basically when you introduce an agent into a system, and it can learn with a reward punishment algorithm. Um, so for supervised learning, when the data is discrete and we have labels, we're doing a classification or categorization. For example, what we want to predict is discrete. By saying discrete, I mean it's categorical, like a cat or dog or anything else. But when it's continuous, like a number, I want to predict how much this car will emit, how much CO2 it will emit before making it. So we're talking about a precise number, like 140 or something like that. So we're doing here regression. And when it's unsupervised with discrete data, we're doing clustering, which is the example that I gave for the bank. And when it's continuous, it's could be a dimensionality reduction. So for artificial intelligence projects, we follow a this um, So we follow this approach where we have business understanding first. We want to know what is the business, um, what is the exact domain, and to learn also whether its KPIs and what makes it special. And then we have data understanding. We get familiar with the data and understand it in a way to know um, if all the data is um, what is the temporal um, what is the temporal dimension for the data, for example, and also know what features we have and what is the data there or the target that we want to predict eventually. Um, and then the data preparation, where we clean the data. For example, we place missing data um, and remove data um, there is not or is very correlated to the target data, and some other stuff that we do that I can dive into maybe in some next videos. And then we'd have the modeling part where we try to use different algorithms to know which one is better. And talking about better, we have the evaluation. So we have a lot of metrics to know how the model has really performed. And then it is a iterative process. So if we are not satisfied with our evaluation, we usually go back to the business understanding or the data understanding to prepare the data better and uh, re-execute the model, and then we deploy uh, the the model that we have. Uh, Deep learning. Uh, so deep learning is a subset of machine learning where we use neural networks. Uh, it was first created by Frank Rosenblatt, um, where he created the multi-layer perceptron. Was very popular, but other machine learning techniques did perform better in the 90s, and deep learning models need a lot of computation power, which wasn't available back then, but did um, it did get very popular nowadays. For example, ChatGPT is working with a technology called transformers, which is based on a lot of neural networks. So there were some key factors to why deep learning became more popular these years. One of which is ReLU. Well, it's a mathematical function that simplified calculations a lot, and GPUs a lot of with gaming. So gaming gave us access to better GPUs that can help us with that computational power that I was speaking about. And rebranding. So it was called neural networks. It was referred to more to but by neural networks, but it was rebranded as deep learning, which made it a bit more famous also. It's inspired by how the neurons in our brain work. um, yeah, it's the same architecture. So, for example, here's a neural network, very simplified, uh, on how to predict the price for a given house. So, first of all, we have the input layer, and a hidden layer could be more of one. And we have the output layer. So for example, here we have features. It could be data in a CSV format or Excel, and would have a feature like the area of the house, the number of bedrooms, the distance to city, and age. And here we these neurons would have a parameter called the weight and the bias. And the model works by recalibrating the weights and the biases that were at first created in a random manner. And it keeps evolving and training. This is what training is. And uh, to get the right weights and biases, to have the best model. And I'll talk about how it works. So, for example, we have an algorithm to know how what is the best weights for the model. So we use a an error function. For example, here y y um, y tilde is the predicted values, and y is the true value. Remember the um, supervised learning. We do have the data for this. This is the training data, and we calculate the distance between the predicted value and the correct value, and we try to minimize this function. So we would calculate the gradient and try to find the minimum. But of course, um, um, it's not always as pretty as this. In reality, we would face something more like this, and we need to find the best weights for the model that minimizes that error function. So we have a very performant model. Some types of neural networks. We have the classical deep neural networks, the convolutional neural networks, which is good for for image classification and for signal for when dealing with signals as well. And the recurrent neural network, which is a neural network that you would choose when you have data that is um, that has some temporal um, some temporal meaning. Yeah, I mean, when the data X that you want to predict is linked to the data X minus one. So it has a semantic, temporal semantic. For example, when I want to, let's say, predict a stock price for some company, for Microsoft, in for tomorrow, so I would need the data for today and yesterday to make the prediction for tomorrow, which is not the case for when dealing with pictures, for example. So these are the most famous neural networks, and I hope you liked this video. I'll try to create more, yeah, and go more in depth. And if you have any requests over a subject that you want me to talk about, you can comment it. So yeah, thank you guys.